The human body holds a secret that only reveals itself when we stop eating. In those quiet hours, when no calories enter and the digestive system falls still, a different form of intelligence awakens deep inside ourselves. Modern science shows that the moment the body senses a fasting state, it begins a cascade of microscopic repairs that almost look intentional, as if we are wired to live longer when we occasionally step away from constant feeding. Mitochondria become more efficient, damaged proteins are cleared away, and survival pathways switch on like emergency lights, guiding our biology back toward balance. Researchers now describe fasting not as deprivation but as activation, a switch that transforms ordinary cells into resilient, adaptable versions of themselves. What follows is the fascinating story of how a simple pause from eating can extend life, sharpen the mind, and regenerate the body in ways that modern medicine is still trying to fully understand. Fasting begins with something surprisingly immediate. The body shifts from using glucose to tapping into stored energy, a natural process that humans are biologically built for. As insulin levels fall, fat stores release fatty acids, and the liver converts them into ketones. These ketones are not just fuel. They act as signaling molecules that tell the body to strengthen its defenses. Scientists have discovered that ketones help protect neurons, support memory formation, and stimulate the growth of new brain connections. This early stage of fasting already introduces a protective layer to the brain that many people feel as mental clarity and stable energy. At the same time, fasting lowers levels of inflammation, something deeply connected with aging. When the digestive system rests, the immune system recalibrates. Pro-inflammatory markers decrease, allowing cells to repair without interruption. The gut lining also begins to strengthen itself, tightening the barrier that prevents toxins from leaking into the bloodstream. A healthier gut directly supports a longer life because it reduces the constant immune activation that slowly wears down tissues over many years. Another change happens in the blood. Growth hormone rises dramatically during fasting, sometimes increasing several times above normal. This hormone helps preserve muscle mass, encourages fat burning, and supports faster recovery from cellular wear and tear. Many people assume fasting weakens the body, but the hormonal shift actually does the opposite. It optimizes the body to maintain strength while using resources more efficiently. As the hours of fasting continue, the body senses a shortage of easily accessible energy and begins prioritizing what to repair first. Damaged mitochondria, misfolded proteins, and old cell components become fuel. This process, known as autophagy, is one of the most studied mechanisms linked to longevity. Autophagy acts like a recycling system that saves the cell from deterioration. When this process runs properly, the risk of age-related diseases decreases because the cell stays cleaner and more functional. Scientists believe this is one of the key reasons fasting is connected to greater lifespan in animals and healthier aging in humans. Fasting also affects metabolic flexibility, the body's ability to switch between energy sources. When this flexibility is lost, people become more prone to chronic diseases. When it is restored, everything from blood sugar control to heart function improves. Studies show that even short, regular fasting periods help the body become more adaptable, making energy use smoother and more efficient. This adaptability is a strong predictor of longevity because it shows that the body can handle stress without breaking down. The heart and blood vessels also respond to fasting in remarkable ways. Blood pressure gradually decreases as the body becomes more sensitive to nitric oxide, a molecule that relaxes blood vessel walls. Cholesterol markers shift, with reductions in triglycerides and increases in beneficial particles that help clear the arteries. These effects create a long-term shield against cardiovascular aging, one of the leading causes of mortality worldwide. Another overlooked effect of fasting is the improvement in cellular communication. Cells use signaling pathways like AMPK, mTOR, and sirtuins to decide whether to grow, repair, or conserve energy. During fasting, these pathways shift toward longevity mode. AMPK boosts energy production and increases antioxidant defenses. Sirtuins support DNA repair and mitochondrial efficiency. mTOR decreases its activity, slowing unnecessary growth and focusing instead on maintenance. Together, these changes create an internal environment in which cells are more likely to survive longer and stay functional. As these processes unfold, the body also becomes more sensitive to the hormone leptin, which controls hunger and energy balance. Better leptin sensitivity means the brain receives clearer signals about when the body needs food and when it doesn't. This helps prevent overeating and supports a stable metabolism over time. All these changes combine into something scientists describe as hormetic stress, a small controlled challenge that makes the body stronger. Fasting is a mild stressor, but the response it triggers is powerful. The body learns to protect itself, conserve resources, and regenerate from within. Over many months or years of regular fasting, these small improvements accumulate into noticeable changes in longevity, vitality, and resilience. As the fasting window continues, the body begins shifting into deeper repair cycles that go far beyond simple energy use. The bloodstream becomes less crowded with glucose and lipids, allowing cells to operate in a cleaner internal environment. This reduction in circulating fuel lowers oxidative stress, which is one of the main contributors to cellular aging. Oxidative stress occurs when unstable molecules known as free radicals damage DNA, proteins, and cell membranes. Fasting reduces this burden by decreasing the sources of metabolic waste and enhancing the body's antioxidant defenses. Over time, this contributes to a slower rate of cellular decay and a longer functional lifespan for many tissues. One of the most intriguing discoveries in modern longevity science is the way fasting affects stem cells. In various animal studies, fasting activates dormant stem cells, particularly in the intestines and muscles. These stem cells begin to regenerate tissues more efficiently, replacing old or damaged cells with newer, healthier ones. This regenerative effect is essential for maintaining vitality as the body ages. Although research in humans is ongoing, early data shows similar improvements in the resilience of tissues that normally degrade with time. The immune system also undergoes a significant transformation during fasting. As insulin levels drop and energy sources shift, old immune cells that are less effective or overly inflammatory are broken down for energy. This makes space for the production of new, more efficient immune cells during the refeeding phase. The result is a younger, more balanced immune system that is better at preventing chronic inflammation, a major driver of accelerated aging. This renewal process helps the body stay resilient against infections and internal damage that accumulates during adulthood. Another fascinating aspect is the effect on the microbiome. When fasting, the digestive tract changes its rhythm. Beneficial bacteria that thrive in low-sugar environments begin to flourish, while harmful bacteria that rely on constant carbohydrates are deprived. This shift leads to a healthier microbiome composition, which supports better digestion, stronger immunity, and improved metabolic control. A balanced microbiome is closely linked to longevity because it plays a critical role in nutrient absorption, inflammation regulation, and even mental health through the gut-brain axis. Fasting also enhances insulin sensitivity, a key marker of healthy aging. When the body becomes more responsive to insulin, it can regulate blood sugar more effectively, lowering the risk of metabolic disorders over time. Persistent high insulin levels are associated with accelerated aging in many tissues, including the skin, blood vessels, and organs. By allowing insulin to drop regularly, fasting gives the body an opportunity to restore metabolic balance, reducing the biological stress that comes from constant glucose spikes. As the body adapts further to fasting, blood pressure and resting heart rate often improve naturally. This is partly due to the reduction in inflammation and improved salt balance, but also because the cardiovascular system becomes more efficient. Blood vessels become more flexible, the heart pumps more effectively, and the overall workload on the cardiovascular system decreases. Over years, these small improvements add up to a significantly lower risk of age-related heart disease. Many people also notice that fasting improves mental clarity in ways that feel surprisingly natural. Ketones provide a steady energy source for the brain, reducing the fluctuations that come from glucose-based metabolism. Studies show that ketones support neurotransmitter balance and strengthen the protective myelin layers that help signals travel quickly between brain cells. This contributes to better focus, sharper memory, and greater cognitive resilience. Because cognitive decline is one of the strongest predictors of reduced lifespan, supporting brain function is an essential part of the longevity story. Another vital area impacted by fasting is the regulation of growth pathways. When food is constantly available, the body prioritizes growth and storage. But during fasting, these growth signals reduce, allowing cellular repair mechanisms to take over. This shift helps lower the activity of pathways associated with rapid aging, such as IGF-1 and mTOR. By reducing these signals intermittently, fasting helps the body avoid unnecessary cell growth and encourages cells to focus on survival and maintenance. This has been linked to a lower risk of cancers and age-related degenerative diseases. In the later stages of fasting, the body becomes more efficient at conserving nutrients and managing energy. Cells begin to recycle amino acids and other components in a sophisticated way that reduces waste and improves function. This optimization allows the body to support essential tissues like the brain and heart even when external energy is scarce. Over time, this increased efficiency contributes to longer cellular lifespan and improved overall energy stability. Finally, fasting improves circadian rhythms, the internal biological clock that regulates sleep, hormone release, and metabolism. When eating patterns are aligned with natural daylight hours, circadian rhythm strengthens, leading to better sleep quality and more stable energy during the day. A well-regulated circadian system is a major factor in longevity, as it influences nearly every biological process associated with aging. As the fasting cycle continues, and the body becomes more accustomed to this pattern of metabolic rest and renewal, deeper mechanisms associated with longevity begin to unfold. One of the most significant changes involves the way cells handle damaged DNA. Every day, DNA experiences small breaks and errors due to environmental stress, metabolic activity, and natural aging. Fasting increases the activity of DNA repair enzymes, allowing cells to fix these issues more efficiently. Over years of consistent fasting, this enhanced repair system can slow the accumulation of genetic errors, which is a major factor linked to aging and disease. Another area that experiences profound benefits is the liver. During fasting, the liver gets a break from constantly processing nutrients, sugars, and fats. This rest allows it to clear out accumulated fat droplets that can contribute to fatty liver disease. A healthier liver improves metabolic control, detoxification capacity, and overall hormonal balance. Because the liver is central to almost every metabolic process, maintaining its health directly supports longevity. Muscle tissue also adapts in a surprising way. Even though no food is coming in, the body protects muscle mass by increasing the production of growth hormone and by using fat stores for energy instead of breaking down muscle proteins. This protective response is especially strong in individuals who combine fasting with light physical activity. Maintaining strong, healthy muscle tissue is essential for long-term health because muscle is linked to metabolic stability, mobility, and protection from frailty in older age. Fasting also influences the way the body distributes fat. Visceral fat, the fat stored around internal organs, is particularly sensitive to fasting. This type of fat is strongly associated with accelerated aging, inflammation, and metabolic dysfunction. By reducing visceral fat, fasting lowers the risk of heart disease, diabetes, and other chronic conditions that shorten lifespan. The gradual reduction of this harmful fat also improves hormone balance, including cortisol and estrogen pathways, which play a role in aging and stress management. Another powerful aspect of fasting is its ability to increase cellular stress resistance. When the body senses a break in external energy, it activates genes that protect against heat, toxins, and oxidative damage. These genes help cells survive under challenging conditions, making them more resilient over time. This improved stress resistance is one of the reasons fasting is consistently linked with longer life in multiple species, from simple organisms like yeast to more complex animals. The brain continues to benefit as well. Fasting raises the production of brain-derived neurotrophic factor, a molecule that helps brain cells grow, repair, and communicate. Higher levels of this molecule are associated with better learning, stronger memory, and greater emotional stability. Over time, this improves cognitive longevity, making the brain less vulnerable to age-related decline. Another fascinating effect is the improvement in metabolic rate. While long-term starvation decreases metabolism, controlled fasting does the opposite. The body becomes more efficient at using energy and transitions smoothly between fuel sources. This flexibility helps stabilize weight, lower inflammation, and support long-term metabolic health. Maintaining a healthy metabolic rate is essential for longevity because slow, inefficient metabolism is linked to faster biological aging. Fasting also influences blood markers associated with aging. Levels of inflammatory cytokines decline, antioxidant capacity rises, and glucose variability becomes more stable. These changes reduce the internal wear and tear on tissues that usually accelerates with age. When these markers stabilize, the risk of chronic illness decreases significantly, contributing to a longer, healthier life. Another striking benefit involves cognitive focus and emotional balance. Many people report a sense of calm during fasting, partly due to the stabilization of neurotransmitters, and partly because ketones create a steady, uninterrupted supply of energy to the brain. This mental stability reduces stress chemicals like cortisol, which in high amounts are linked to accelerated aging. By maintaining calmer neurological and hormonal patterns, fasting supports long-term mental and emotional resilience. Finally, fasting influences longevity by improving mitochondrial biogenesis, the creation of new mitochondria. These tiny structures are the engines of the cell, responsible for producing energy. Over time, mitochondria become less efficient and generate more waste. Fasting triggers processes that remove older mitochondria and replace them with new, stronger ones. This renewal increases energy levels, slows cellular aging, and helps maintain vitality into older adulthood. As fasting becomes a regular pattern in someone's lifestyle, The accumulated effects begin shaping the long-term trajectory of aging in ways that modern research is only starting to quantify. One of the most influential long-term effects is the sustained improvement in metabolic health. When fasting cycles repeat over weeks and months, glucose control stabilizes, insulin spikes become less frequent, and the overall metabolic environment becomes calmer. This reduces the constant cellular pressure that comes from fluctuations in blood sugar, helping tissues stay functional for a longer period of time. Over the long term, blood lipid profiles also shift in a beneficial direction. LDL particles become less oxidized and less likely to contribute to plaque formation. HDL levels can rise, improving the body's ability to transport excess cholesterol away from the arteries. Reduced triglycerides support heart health and decrease the burden on the liver. Taken together, these changes create a cardiovascular environment that is more resistant to aging, providing strong protection against one of the most significant factors that influence human lifespan. One of the more subtle but powerful benefits of fasting is its impact on cellular aging clocks. Every cell contains telomeres, the protective caps at the ends of chromosomes that shorten with age. While fasting is not the only factor influencing telomere length, studies suggest that metabolic stability, reduced oxidative stress, and lower inflammation help slow the rate of telomere shortening. By decreasing the conditions that accelerate telomere loss, fasting helps maintain the integrity of cellular DNA for a longer period. Another area deeply impacted by fasting is hormone balance. As body fat decreases and insulin sensitivity improves, a number of hormones begin to stabilize. Cortisol patterns become more predictable, which improves stress response. Thyroid hormones regulate more efficiently, supporting energy and metabolism. Sex hormones also tend to balance more naturally, especially in individuals whose metabolic health improves over time, reducing symptoms linked to hormonal imbalances and age-related changes. Fasting also improves lymphatic flow, the system responsible for clearing waste products from tissues. When inflammation drops and metabolic waste decreases, the lymphatic system can clear cellular debris more effectively. Better lymphatic flow supports immune health, decreases swelling, and improves the cellular environment throughout the body. Over many years, this contributes to slower tissue degeneration and improved longevity. Another compelling aspect is the effect of fasting on organ health beyond the liver. The pancreas becomes less strained because it no longer needs to release insulin constantly. This rest improves pancreatic function and reduces the risk of insulin resistance. Kidneys benefit from reduced metabolic load, giving them time to recover and maintain better filtration efficiency. Even the skin, the body's largest organ, shows signs of improved clarity, reduced inflammation, and healthier aging due to better hormone balance and lower oxidative stress. The mental and emotional landscape also benefits in long-term fasting routines. The consistent rise of ketones supports better brain energy stability, which improves focus and cognitive resilience. Fasting reduces the rapid shifts in glucose that often trigger mood swings or mental fatigue. People who fast regularly often describe a steady sense of clarity and calm that becomes more noticeable over time. This emotional stability helps reduce chronic stress, a major contributor to accelerated aging and disease. As time continues, the structural integrity of the body also improves. Bones maintain better density due to improved hormonal signals and reduced inflammation. Joints benefit from decreased inflammatory cytokines, which reduces stiffness and supports mobility. Because movement becomes easier, individuals are more likely to stay active, reinforcing the positive cycle that supports healthy aging. Another long-term benefit of fasting revolves around the way it shapes lifestyle patterns. People who fast regularly often become more conscious of the timing and quality of their food. This encourages healthier habits, improved portion control, and a greater understanding of hunger and fullness cues. These behavioral changes reduce the chances of overeating and support long-term metabolic balance. This indirect effect plays a significant role in longevity because lifestyle patterns are one of the strongest predictors of health span. Fasting also strengthens the body's ability to handle environmental stress. Over time, cells become more efficient at producing heat shock proteins, antioxidants, and protective enzymes. These defenses help the body survive challenges such as toxins, temperature shifts, and infections. When the body is better equipped to handle stress, the wear on cells decreases, slowing the biological aging process. In the broader picture, fasting creates a biological environment where the body is not constantly burdened by excess energy intake. Giving the digestive system regular breaks allows more resources to be directed toward recovery, repair, and regeneration. As these processes accumulate over years, they shape a healthier aging trajectory marked by stable energy, clearer thinking, and reduced risk of chronic diseases. Ultimately, fasting supports longevity, not through a single mechanism, but through a complex network of cellular, metabolic, hormonal, and neurological improvements. Each fasting cycle provides a small boost, and the repetition of these cycles over time creates meaningful, measurable changes in how the body ages. By activating repair systems, improving metabolic flexibility, supporting healthier tissues, and promoting a cleaner internal environment, fasting aligns the body with its natural capacity for resilience and long life. The science continues to advance, but the core discovery remains the same. Giving the body time without food activates some of the most powerful longevity pathways known in modern research.